Hello everybody, this is Statistical Quality Control, also known as INSY 4330. We are Group 7 and this is our project, Predicting Disease Outbreaks Using Twitter. Fairly self-explanatory what we're trying to accomplish, but essentially we're trying to see if we can use various tweets and the frequency of those tweets to determine if there is an outbreak of a certain disease in a specific region. The general outline for this project was that we first had to collect the Twitter data using Python. So we downloaded different elements in order to get Python and manipulate it so that we could download tweets in real time according to different keywords that we found. And then we used MySQL as a database in order to store all of those tweets. Then we were able to go back through and analyze the data using Excel. We were able to export from MySQL into a CSV file in order for Excel to read it. Once we broke it up into Excel, we were able to then examine by region and try to determine a rough location of where the tweets were coming from. And from there, we were able to then analyze using Minitab, looking at a specific control chart for a specific region during the peak period that tweets normally would occur. And then finally, we validated all of these using news articles and looking at the CDC website to make sure that our data was valid for the times that we collected. As described previously, one of the first steps is to set up Python and to set up a database. So for our group, we were doing this on a Mac. So we downloaded Python and Terminal, and there's many different setup tools you have to download, and we also downloaded a specific code called Tweepy. Now, depending on what you'll need to do for your project or whatever problem you're trying to tackle, you may need to download different things. So essentially, in this case, Google really is going to be your best friend. So we created a Twitter developer account and we modified our Python code with the information that we got from the Twitter developer account. That is completely free and very easy to do. Again, you can Google it and you'll find very clear instructions on how to set up a developer account. Now, in order to write to a database, we downloaded MySQL. You have to set up an Oracle account for that, but again, it's free and fairly simple to do. Once you download MySQL, you'll also need to download the MySQL Workbench, and then you'll need to download and install the MySQL DB for Python. Essentially what that is, it's a way for Python to then communicate with MySQL. And once you get all of that set up, then you should be able to start collecting your tweets. Here is our Python code. Now, it's going to be impossible really to go through this step by step so that you'll understand completely, but I can give you the general gist of what we're doing here in our code. You'll see up top there's something that says set terms. Now what that is that's essentially where we're putting in the keywords that we're trying to pull in from Twitter. This includes hashtags, or if there's a word out there that's not in a hashtag. Below that you'll see set lang, and that is in order to set the language. Obviously we wanted to collect in English for our purposes. Farther down, you'll notice there's a lot of things in red. Those are comments. It's very important to comment throughout your code so that you can not only understand what's going on, but also so that if something's not working properly, you can go ahead and comment that out in order to continue to debug your code. Farther down the line, there's different code keys and things. That's what we talked about previously that you'll get from your Twitter developer account. That's where you'll put that all in there. That way Twitter knows that you have a developer account and you're able to access these tweets. Next, you'll see all these print commands. Essentially what that is when you're running Python, when you run this code, in the terminal window, it will actually show all of those things that we're telling it to print. So it'll show the text, it'll show when it was created, the tweet ID, everything that it has possible to show, it'll show in the terminal window. And next, below all those print commands, all of those are in order to write to our database in MySQL. So once you go ahead and put all of those together, it's going to contact Twitter, it's going to pull a tweet based off of the language and terms, it will print those in the terminal window and immediately upload those into MySQL, and that's how you have your Python code.
So this basically just shows what your MySQL workbench will look like. At the top, that's where you search for your specific table that you've downloaded all of your tweets into. For our project, we had, of course, different things that we were looking for as far as tweet and what time it was created and the tweet IDs. But for your project, of course, it'll be specific to yours. As we talked about in the previous slide, the Python code will be able to specify which things you're trying to get from a tweet in order to put this into MySQL. As we mentioned, for our project, we were trying to see if we could predict an outbreak for 2 different types of diseases. So these keywords were just some of the things that we were looking for when we were collecting tweets. You can see that the hashtags next to the symptoms were the keywords that we used to search and put into our Python code to collect our tweets. These just specifically correlate to 2 different types of diseases, and you don't have to include the hashtags in your Python code because Twitter will search whatever words you're looking for with or without the hashtags. This is just the information we chose to collect from the tweets. For our project, we chose to collect the actual tweet, the time the tweet was created, the tweet ID, and their screen name, and the source, whether or not it came from Twitter for iPhone, Android, BlackBerry, things like that, and the location of the tweet. Of course, this location was not exactly the location of the tweet, it's just whatever the particular person inputted as their location, but there is also a way that you can get the coordinates of the tweet if you just research it.
This is the graph that we used for our region breakdown in our Twitter project, and this is also the current graph that the CDC uses for a region breakdown in their disease control. The team used the VBA code in order to search for each tweet's location and assigned it to the correct region that you saw on the map in the previous slide. We also normalized the data based on population. The normalization was done with frequencies in an attempt to prevent densely populated states for outweighing the lesser populated states, for example, California, New York, other highly populated states. And text mining is a search and remove for retweets, common jokes, celebrity tweets, and also they were used for provide a misconception about the data. They were removed for that purpose. We grouped the final count data per hour for each of the 4 regions. Then the Excel file was exported into Minitab.
After the Excel section, the team imported the filtered data into Minitab for further analysis. We created a time series plot to visualize peak period tweeting times. Each region had its own specific peak period. Only the tweets from the peak period were analyzed in the control charts. The filtered data most closely resembled that of a normal distribution. For our control charts, we chose an individual moving range to monitor our data. The moving range chart plots the difference between 2 points. We also included a plot of the individual values. Here shown are the IMR control charts for the strep throat and salmonella tweets. As you can see, 4 sigma limits were used. We did this because we wanted to reduce the chance of type 1 error, or also known as false alarms. When the upper bound of a control chart is exceeded, further investigation should be done to validate the out-of-control points. In each of our control charts, at least 1 point exceeded the upper bounds. We then researched each point for further validation.
On the left, you can see a heat map of our data that we created using the Google Doc Excel file. And to the right is a comparison map of an outbreak that occurred during that time while we were collecting data. And as you can see, the states in the West region compare pretty similar to each other as to our data map and the actual outbreaks.
For our validation of our findings, it's going to be different for your project, but during our data collection, the southern region had an outbreak, so we just used articles that we found on Google and news websites, and we found this heat map to show that there was an actual outbreak in the south during our data collection time. We also used healthmap.org, which is a really cool website that shows you all of the outbreaks. You can type in different diseases and search those, and it'll bring up all of the articles that they have that are related to that disease if there was an outbreak. And that is the methodology of how we conducted our project. Thank you for listening, and good luck with your projects.